Hi there, it's Mike, and we're going to start solving our LinkedIn problems. I think there'll be about 50 series about this, and in each episode we'll solve one problem. We will start from the easiest problems and continue to hard ones. And our task is to return two indices of our list so that the elements with these indices would add up to our target number. Okay. I also I see that we should have only one solution, so we can't have just two solutions for one list. Okay, and I can return answer in any order. So, and we have some examples. For example, we're given a list with such elements, and our target is 9. So in output we should return a list with 0 and 1. If we check this 0 index and the 1 index, it's 2 and 7, and if we add up 2 to 7, it's exactly 9, so it's correct. And here's the explanation of this. So let's start writing our code. Okay, I'll write code in Python. I think it's just convenient for me. If you prefer any other language, you can just use other language. So we have a function to sum, and we're given arguments such as nums and target. Okay. So what should we do first? First, I think we should consider our constraints. Okay, let's do this. For this, I'll just write some ifs. Okay, the first constraint is that our array should be greater than 2 and less than 10,000. So what do you think? I think that we should check if it follows the constraints, and if it falls, then we'll just raise an error. Let's do that. Okay, then it will be another constraint is basically that our length of nums is, okay, I'll write like this notation, and it just says that if we have our list with a length of 2 or less, or we have a list with a length of more than 10,000, we will just raise an error. Okay, let's raise here value error, I think, and let's consider the next constraint, but I see that we should check it for the next constraint for each number in list. That's why I'll leave it for later. So then let's check the third constraint. Basically, if then, so we are going to main algorithm, and for this I think we can just iterate our list and just sum up maybe two numbers, and if those two numbers fit to target, the sum of those numbers fit to target, and then we will return the answer. Okay, I think actually I don't know, because it may be that for example, we have a list we have a list of, for example, three elements. Let it be 1, 2, 3, and our target is 4. And what do we get? 1 plus 2. It doesn't sum up to target, and 2 plus 3 as well also does not. So, and we'll just need sum up the first and the last element. So basically we need to check all possibilities for we need to check all possibilities of sum of our elements. I think so, actually. So basically, how would you explain this? Basically, we have a list with 4 elements, and right now I want to write a code that iterates over this list, and for each iteration it just takes 2 elements. 2 elements at a time. For example, on the first iteration it takes the first and the second element of the list, and on the sum up step. On the second iteration it takes the third and the fourth elements and sum up them. But what are the problems here? Let's imagine that we have answer. For example, to answer correctly, we'll need to take the first element of the list and the last element of the list. And there are 4 elements in the list. So our code just won't work for this case. And for this we need to use another algorithm. Okay, if we iterate over a list and let's draw that, because I think it's very complicated. So let's imagine that we have a list, and take, for example, on each iteration 1 number. Let's imagine it's the first iteration. Yes, we take 1 number, and this number we add up to the rest elements of the list. For example, we add it plus 2. If plus 2 equals our target, for example, t is our target, equals to our target, then we just return indexes of those elements. If not, then we continue and add 1 plus 3. If this case doesn't work as well, then we will add 1 plus 4. And if there are no matches in the list, then we will just return an empty list, I think. Yes, so I think it's actually useful. It can work, but if we'll take the second number, what will we do? And I think the second number will not iterate. So the second number will sum up to 3 and to 4. In the first time to 3, and in the second time to 4, and so on. Then it goes just 3, and we left only 4. We can use that. We'll try to use it. So basically we are iterating our list, and on each iteration we take this element and add up this element to other elements, and if the sum of those 2 elements equals target, then we just return the indexes of those elements. Okay, I'll just try that. Okay, let's write our loop. I think we'll need to iterate over indexes. Yes, it'll be more convenient. And here oh no, I think we can use just enumerate function to get index and value. Enumerate nums, and here is index and the second is value. Yes, and okay. Then we just so we'll just need loop in a loop. Nested loop, it's not good. Yeah, it's not good. But let's try at least this algorithm. Okay, let's try it. Let's iterate over range. So we can't return the sum of two equal elements. That's why we can't iterate. Okay, wait a minute. Okay, yes. So let's look to our diagram, and yes, it's a mess. Okay. I think in range, and we will handle the range of the rest of the elements, and for this we will just we'll just write the difference of so we need to iterate over the rest of the elements in the list. Yes, let's do this. For this we will calculate the difference between length of the list and the current index of the list, and it will be a difference, so the rest of the elements, and we will iterate over indexes of the rest elements. Okay. and let's just check if v plus nums I named it the same. Okay, let's name this n. V plus nums n. Here we just check if our sum equals to target. Then we'll just return those two indexes. Yes. Okay. I think it should work actually. So let's check this. Let's check. Okay. And we got an error. And what does it say? We were given this list and this target. Oh, we failed the first test. It's great. We use return outside of the function. What did I miss? Oh, I didn't notice the indent. It isn't very convenient to write code here. Okay, we passed the first test, it's good, but we failed the second case. And we just returned 0, 0. So 3 plus 2, it doesn't equal 5. Ah no, 3 plus 3, and it equals 6, that's why we failed. But it shouldn't iterate over the same elements. Yeah, it should. Or I'm missing something. Okay, I have a low battery. 6%. That's bad. I hope I'll pass this until my phone battery is low. So what can I do here? I think we should check if n and v are not the same elements. I think it's very bad code actually. If v equals n, oh no, yes, if v equals n, maybe, no, if nums I equals equals v, our value, then can just continue to the next iteration. Okay, let's check. Of course we didn't answer correctly. We didn't output anything. What? If our number equals to value is here and number should be okay. Oh, No, it doesn't work like that. We should check indexes, not values. So if I equals to n, then continue. If not, then return the answer. And the same. No, not the same. Now we have null. So what did we do wrong? I don't know, actually. Ooh. What's the problem? Okay, I'll just write what have we got now. So we have a list of values. We have a target. Okay, let's our target be, for example, 4. Okay. Okay, 4. Let it be 4. And in each, no, let it be maybe 6. Yes. Yes, and in each iteration. Oh, I have less than 5%. On each iteration. Okay, and on each iteration, for example, let's start with 1. 1 plus 2 doesn't equal 3, no, 6 plus 3 doesn't equal 6 plus 4, no, continue to 2, 2 plus 3, and it doesn't equal 6, 2 plus 4, it equals 6, so, and we should return in our answer a list with elements of the indexes. So the index of 2 is 0, 1, and the index of 4 is 0, 1, 2, 3. Yes, and we should return this answer. But it doesn't happen here. As we can see, we passed the third case, but failed the second. Okay, can we print something? I don't think. I don't think I should. What's wrong here? I think that I think nothing. For any range, if we okay, it should work, but it doesn't. Maybe minus I and minus 1, because the length is on 1 more than the index. No. Okay, maybe so, minus 1 minus I. So basically 0 minus 0, 0, 1 minus 0, 1, 1 minus 1. Oh, no, we have 4 elements. 3 elements left. Okay, 3 minus 0, 3. Wait, it shouldn't be 3. Mm. 3 minus 0, 3. Minus 1, 2. Okay. 4. And here we have 0 and 1. I think I should increase n. And to 1 here. Oh, just n plus equals 1. I think. No, I don't understand how we pass other tests if we can't pass the first and the second. So, for example, we have 3 items, 3 minus 1, 2, minus I, 0, 2, okay, 2, 4 I in range of 2. The first iteration is 0, we add it to 1, it's 1, it's 1. I understand. It's just wrong. We are iterating over the wrong range, but we should do it next. Okay. We should iterate from the element that we ended to the end of the list. To this we don't need this one. Oh, and okay, the length minus 1. For example, x. For example, 3 minus 1, 2 minus I is 2. Why do we do minus 1? Let's not do. Okay, it's actually wrong here. We should do the next logic. We should iterate from the last element here to the last element of nubs. Yes, it's a bit complicated, but in code it looks like this. Oh. Something like this. No. It shouldn't do minus 1. It's actually passed. Yes. Okay, let's submit the solution and see. Oh, I just hope it works. It really works. Oh. It's been so long for the easiest task. Oh, what a shame. Okay guys, we just passed, and what have we got here? Our code takes 1000 milliseconds. It's 1 second, if I'm not mistaken. Yeah. It's once and more than a half second. It's almost 2 seconds. So, and it beats only 30% of the other people algorithm. Okay. The first LeetCode is done, and it was so on for the easiest task, and I think we'll continue on the next week. So keep in touch, and bye bye.